All right, today we're going to look at a piece of engineering that honestly feels like pure magic. We're breaking down how some apps can work flawlessly, even when you've got 0 bars and no Wi-Fi in sight.
So let's just jump right in with a puzzle that sounds completely impossible. Picture this. You're on a train, way out in the middle of nowhere, miles from any kind of signal. How in the world could an app on your phone know in real time exactly where that train is?
Well, to crack this little mystery, we're going to look at a real-world example. There's this incredibly popular app from India that seems to do exactly that. This impossible thing.
Meet Where Is My Train? This app is a huge deal. It was launched back in 2015 by a small startup called Sigmoid Labs, and it just absolutely exploded. We're talking over 100 million downloads. And its killer feature? Live train updates, completely offline. It was so effective, so revolutionary, that Google actually bought the company in 2018, pretty much to figure out its secret sauce for building products for people with limited connectivity.
Okay, so how on earth does it pull this off? Now, the first thing that probably pops into your head is GPS, right? And that totally makes sense, but it's not the real secret here, not by a long shot.
To really get what's going on, we have to look beyond GPS. The actual solution is way, way clever, because it's designed to work with the messy reality of the world we actually live in. The developers themselves had a cool name for it, the tower trick.
But first, let's just be super clear about what GPS even is. Your phone isn't sending any signals up to space. It's totally passive. It's just a listener. Up in orbit, satellites are constantly beaming down these incredibly precise time signals. And if your phone can hear at least 4 of them, it can do some quick math to figure out its exact spot on the globe. It's a one-way street, which is why it works without any internet. But here's the twist. While the Where Is My Train app can use GPS, that's not its main move. GPS can be unreliable, right? It doesn't work well in tunnels or sometimes in really remote spots. The app's core magic, the real secret, is something way more, well, down to earth. So here it is, the tower trick. It uses the cellular network itself. See, even when you have no internet service, your phone is constantly chatting with nearby cell towers just to stay on the network. This app piggybacks on that conversation. It watches the unique IDs of the towers you pass, it sees how the signal gets stronger and weaker as you move, and then it takes that whole pattern and compares it to a map of all the railway lines that it has stored locally on your phone. It's basically making a brilliant deduction, saying, hey, we're moving at 80 kilometers an hour, passing these specific towers in this order that perfectly matches the Mumbai to Delhi line. We must be on that train.
Now, the key thing to understand is that this isn't a perfect pinpoint tracking system. It's a very, very educated guess, a probabilistic estimation. And that's exactly what makes it so brilliant. The engineers didn't try to fight the reality of spotty networks. They designed a system that thrives in it. And that kind of thinking, well, it goes way beyond just one app. In fact, this whole design philosophy actually has a name in the software world. It's all part of what's known as the offline first playbook. And this slide really nails the difference. Most apps you use are online first. They're basically useless without the internet because their brain is on a server somewhere far away. Offline first apps completely flip that script. Their brain is right there on your device. They're built to work with local data first, and then they just sync up with the cloud whenever a connection happens to be available. So why would a developer go through all this extra trouble? Well, the benefits for you, the user, are massive. The app feels way faster because there's no network lag. It's way more reliable since it doesn't just die in a tunnel. It can even save you money on your data plan. But honestly, the most important thing is, it just works all the time, which makes for a much, much less frustrating experience.
But look, working offline is only half the battle. When you do get an internet connection, especially if it's a slow or expensive one, you have to make sure your data is as small and efficient as it can possibly be. It's kind of like you got to put your data on a diet. There's a great rule of thumb developers use for this. It's about picking the right format for your data. The two big options are JSON, which is basically human-readable text, and protocol buffers, or proto for short, which is a super compact binary format. The choice really comes down to one question. Is this for a human to read or for a machine to process?
I love this analogy. JSON is like a comfy t-shirt. It's easy for developers to read and work with. Proto is like a high-performance racing suit. You wouldn't wear it every day, but for machine-to-machine speed, its efficiency is just unbeatable.
And you can see the difference here. Proto is about 3 times smaller and can be processed more than 10 times faster. On a slow network, that's not just a little better, that's a total game changer.
So, we've seen how to engineer for unreliable networks. But there's another real-world constraint that's every bit as important: user privacy. And this leads to a really thorny question. How do you build an app that can get data from the internet without it being able to leak your private data back out to the internet?
This is a fundamental problem in app design. You want your map app to download new maps, but you definitely don't want it uploading your entire location history. Your health app might need to download new workout plans, but you sure don't want it selling your heart rate data to advertisers.
One really fascinating proposed solution is a concept called privacy capsules. The core idea is to split an app's operations into 2 totally separate states that are enforced by the phone's operating system itself. You've got an unsealed state and a sealed state, and the app can only ever be in one at a time.
The rules here are simple but incredibly powerful. When an app is unsealed, it can get on the internet and download whatever it needs, but, and this is the key, it is completely blocked from accessing your private data. No location, no contacts, nothing. Then, it can switch to the sealed state. Now it can access your private data to do its job, but the internet connection is totally cut off. It can never do both at the same time. It's like an airlock for data. So you might ask, well, what if I want to share something? Like you want to send your workout data to your coach. The system allows for something called selective declassification. The app has to specifically ask for permission to send one specific piece of data to one specific place. The phone's operating system then shows you a clear pop-up, putting you, the user, in complete control.
So let's tie all of this together. We've talked about tracking trains, designing for offline, making data efficient, and protecting privacy. And they might feel like totally different topics, but they're all connected by one single powerful idea. The common thread is engineering for the real world. Instead of assuming everyone has perfect internet, unlimited data, and that all apps are trustworthy, these solutions acknowledge reality. They work with constraints, not against them. Cell tower tracking accepts that GPS might fail. Offline first design accepts that networks drop. Proto accepts that data plans are limiting. And privacy capsules accept that not all apps can be trusted.
And this really brings us to a final thought. This whole mindset, designing for constraints, isn't just about software. It's about creative problem solving in general. It makes you wonder, doesn't it? What other impossible problems could we solve just by changing our assumptions and engineering for the world as it actually is, not the one we wish we had?